Hello everyone, today we are going to continue our part 3 of solving proportion and ratio. Question number 19, find the value of x. With this given figure, this is the x. How to find this x? We have to determine the given figure. Our observation, we have 3 lines here, and this line is called parallel lines, and we have a transversal lines. We have 2 transversal lines. So our solution, we have to make or to set up first proportion. How to make a proportion? We can since this is the parallel line, is our guide, so we can use 4 over 10. 4 over 10 equals x over 15. Or the other way, 4 equals to x over 10 equals to 15. Now, after making the proportion, we're going to use cross multiplication or cross multiply. We are going to multiply 10 times x equals 10x, and 4 times 15 equals 60. And after that, we're going to eliminate the numerical coefficient x by dividing by 10 both sides of the equation. And 10 divided by 10 equals 1 times x equals x, and 60 divided by 10 equals 6. So therefore, the value now of x is equals to 6. Number 20. Okay, find the value of x. So we have another figure. Here is a triangle, and there is an indicator here that this angle B divided equally. So this line here, the segment, is called the angle bisector. Once there is angle bisector, our proportion will come to this line from the hypotenuse. So to solve the value of x here, we're going to set up first a proportion. How to set up a proportion? Our basis is this angle bisector. So we will start our proportion. 8 divided by x equals 6 divided by 15. That's how to set up a proportion. Then after that, next step is to cross multiply. 6 times x equals 6x, and 8 times 15 equals 120. Then divided by 6 both sides, just to eliminate the numerical coefficient of x. And 6 divided by 6 now is we have 1 times x equals x, and 120 divided by 6 equals 20. So the value of x now is 20. Or this segment DC, the value is 20. Number 21, find the value of x. The same triangles we have here, and we have also an angle bisector, this segment and this angle divided equally. So that's why we can say that this segment is the angle bisector. Now, find x here. So the same, our basis to set up a proportion is the hypotenuse here, because this is the segment which is the angle bisector. So we will start our proportion from 6 divided by 10, 6 over 10 equals 810 divided by x. So 6 over 10 equals 810 over x is our proportion. Then, next step is cross multiplication. 6 times x equals 6x. 10 times 810 equals 180. Then we're going to eliminate the numerical coefficient of x, which is 6. So that's why we have to divide it by 6 both sides. So 6 divided by 6 equals 1 times x equals x, and 180 divided by 6 is 30. So our value now for x is 30. Next, number 22, find the value of x of the given triangle. So we have to scrutinize first this triangle. There is the same angle, and there is a segment here. So once this segment divided the angle equally, so this segment is called angle bisector. So to solve the x, our we are going to make first proportion. To make the proportion, our guide is the angle bisector, and we're going to start our proportion from 6 divided by 12. So 6 is to 12 equals x over 8. So this is now our proportion. After making the proportion, we're going to cross multiply. 12 times x equals 12x, 6 times 8 equals 48, and we're going to eliminate the numerical coefficient of x, so by dividing by 12 both sides. So 12 divided by 12 equals 1 times x equals x, 48 divided by 12 equals 4. So the value of x now here is 4. Next, number 3, 23. Find the x, and the given we have two similar triangles, and find the x. So our solution is first to set up a proportion. So in this given two similar triangles, we're going to determine the same side. This side is equal here, and this side is also here, the same, and this side is also here. Upon recognize the parts of the two triangles given, so we're going to set up now the proportion 4 over 12. So 4 over 12 equals 8 over x. And after the proportion, we're going to cross multiply. 4 times 6 equals 4x, 12 times 8 equals 96. Then remove or eliminate the numerical coefficient of x. So we're going to divide it by 4 both sides, and 4 divided by 4 equals 1 times x equals x. Then 96 divided by 4 equals 24. So the measurement of x now is 24. Okay, next 24. Find x and y the same. Given two similar triangles, and we're going to find the x and y. How to find this? Of course, we're going to set up a proportion. So we're going to determine the same side of a triangles, the same, and also here the same. Then we're going to make now or set up a proportion 5 over 14. So 5 over 14 in our solution equals 10 over y. Then after this proportion, we're going to cross multiply. 5 times y equals 5y, 14 times 10 equals 140. Then eliminate the numerical coefficient of y, so divided by 5 both sides. Then 5 divided by 5 equals 1 times y equals y, 140 divided by 5 equals 28. So the value now of y is 28. Next, we're going to solve for x, so we will set up again the proportion 5 divided by 14 equals 8 divided by x. Then after the proportion, we're going to cross multiply. 5 times x equals 5x, 14 times 8 equals 112. Then eliminate the numerical coefficient of x, which is 5, divided by both sides by 5. Then 5 divided by 5 equals 1 times x equals x. 112 divided by 5 equals 12.4. So the value of x is 12.4. Next, 25. Find the ratios of corresponding sides of the given connected triangles. So we have two triangles again here, similar triangles. Then we're going to find the ratio. Remember, in making ratios, we have three ways, and the one way is that is a fraction. So we're going to make a fraction. A segment AD similar to segment BC. So that's why we have segment AD divided by BC. The next, we're going to substitute for the value. The value of AD is 8, and the value for segment BC is 12. Then reduce the lowest term. We have divided by 4. 8 divided by 4 equals 2. 12 divided by 4 equals 3. This is a fraction. We have a ratio, and we're going to change this n to 2:3. Next, another way, number 2, we have also here segment AE and segment BE. So there's a fraction, then the substitute now for segment AE is 6, and for the segment BE is 9, and reduce to lowest term, divided by 3 both numerator and denominator. 6 divided by 3 equals 2, 9 divided by 3 equals 3. So 2/3 or 2 is to 3. It's the ratio. Next, number 3, we have segment DA, this portion, segment DA, and the segment CE. And the value for D is 5 and the value for C is 10. And we are going to reduce the fraction, divided by 5, 5 divided by 5 equals 1, 10 divided by 5 equals 2, or 1 is to 2. Next, 26, find the value of A of the given triangle. Okay, first we're going to scrutinize the given triangle. It's a right triangle because of this mark here. So this, since it's a right triangle, so this line here or segment is called altitude. So to find A, we're going to use again a proportion. And to make a proportion, our guide is this altitude. So we're going to start our proportion from 4 over A. Okay? 4 over A equals A over 4 plus 8. And 4 plus 8. We're going to add 4 plus this 4 and 8. This segment here. So then cross multiply. A times A equals A squared. Then 4 times 12 equals 48. Then we are going to factor the 48, becomes 16.3 or 16 times 3. And the square root of 16 is 4. The square root of 3 the value of A. Next, number 27. Find the value of P here. So again, altitude, and this is the hypotenuse of right triangle. So our proportion now is start from 4 over B equals B over 8. Then cross multiply. B times B equals B squared. 4 times it equals 32. Then the square root of 32. We're going to extract this. We will use the radical symbol. And we have now the factor of 32, 16, and 2. Then the square root of 16 is 4. The square root of 2. So the value of B is the square root. The value of B now is 4 square root of 2.